Hello, my name is Andrew Jensen, and this is Group 12's Course Project Video Overview. I'm presenting a dual-task machine learning project focused on diagnostic prediction and consumer segmentation. The project consists of two primary tasks. Task 1, a supervised classification task using the Pima Indians diabetes dataset, where I implemented 5 models. Task 2 was an unsupervised clustering task using the mall customer segmentation dataset, where I implemented 3 models. My objective was to go beyond basic implementation, and I invested over 60 hours into this project. For task 1 in the Pima Indians dataset, I identified disguised missing data, zeros in fields like insulin and skin thickness, where a zero value is biologically impossible. There were two data cleaning strategies that I considered. Strategy 1 was to drop the two features with the most missing data, which were skin thickness and insulin. And then for the remaining missing values, apply KNN imputation with k equals 5 to fill in these remaining missing values. KNN imputation was a technique that I learned from one of the TAs in this course. Or strategy 2 was to drop all rows with one or more missing values. This strategy was based on one of the publications I read written by an author named Pearson. To move forward with this task, I selected strategy 1. This allowed me to retrain a robust training set of 761 rows, which provided a stronger foundation than what I believe to be was strategy 2 of a simple row deletion. For task 1, I evaluated 5 models: logistic regression, SVM, MLP, Gaussian naive Bayes, and random forest. Using grid search CV with 5-fold cross-validation, I conducted an ablation study across at least 10 different configurations to address the bias variance trade-off. I selected the F1 score as my primary metric to ensure a balance between precision and recall, which is critical because missing a medical diagnosis like diabetes is a high-stakes failure. The random forest model was the top performer with the highest F1 score, and glucose was confirmed to be the most significant feature predictor. A unique requirement of this project was the extreme error analysis. I audited cases where the model was 80% confident but technically wrong. I specifically investigated if the KNN imputation that I introduced during the data cleaning process influenced these errors. The audit confirmed that none of the extreme errors occurred on imputed data, validating that my cleaning process did not introduce high confidence bias. For task 2, which was the unsupervised learning task, the data set that I used focused on segmenting 200 mall customers using 3 models, which were k-means, algorithmic clustering, and Gaussian mixture models. Based on an ablation study of the silhouette scores, I identified 11 clusters as the optimal segmentation. Finally, using my professional judgment and the evaluation metrics, I selected GMM as the best model because I believed it handled the non-spherical clusters identified in the t-SNE visualizations more effectively than the other 2 models. In conclusion, this project demonstrated that strategic data cleaning and rigorous calibration are just as vital as algorithm selection. By addressing missing data and auditing on high confidence errors, I transformed raw data into a reliable diabetes diagnostic tool and a clear segmentation map for a mall. Thank you.